is 16 and 16, which is a pair right there. And remember, whatever we circle comes on the outside one time. Is there anything left on the inside? No. So the answer of the square root of 256 is 16. Now, 12 root 24. 24 is not a perfect square, so we're going to break it down into factors. So we're going to go, what are two numbers that you use that multiply to 24? Jack? 6 and 4, you got it. So we're going to go 6 and 4. Now remember, the whole point of this is just finding pairs. And then I'm going to break down 4 into 2 and 2, and that's a pair. I'm not going to break down the 6. The reason I'm not going to break down the 6 is because 6 is going to get broken down into 2 and 3. But is there any more pairs I can make from that by breaking it down to 2 and 3? So there's no point in breaking that down. So remember, whatever number we circle comes on the outside one time. I have a 12 on the outside. I'm going to put a 2 on the outside. And then whatever's left over, not circled, not crossed out, that's 6, goes back on the inside. So on the outside, we have 12 times 2, which is 24 root 6. How many people got that correct? Oh, what happened to everybody else? No? Okay, next one. 6 root 200. So because it ends in 2 zeros, I'm going to go with it 2 and 100. And then 100 is a perfect square. What multiplies to 100? 10 and 10. So now whatever I circle goes on the outside how many times? One time. So I have a 6 on the outside and I have a 10 on the outside. And what's left on the inside? A 2. So this becomes 60 root 2. Okay. So today what we're going to do is we're going to talk about adding and subtracting radicals. When we're adding and subtracting radicals, the first thing you want to do is make sure each radical is completely simplified, meaning like break it down like we did here if possible. Then what you want to do in order to add them, they need to have the same number underneath the radical. We need the same number underneath the radical. And it's very similar to adding variables. If you have a 3x plus, I don't know, a 2x, and you add those, isn't that 5x? Meaning you just add the numbers in front and you keep your variable the same. Well, that's the same rule for radicals. When we're adding radicals, and this is why they need the same number underneath in order to add them, what you're going to do is you're going to add the numbers in front, you're going to add the coefficients, but you're going to leave the actual radical as it is. So 4 root 3 plus 5 root 3 is going to be 9 root 3. And just like with x, if there's no number in front of x, what number is there just invisible, just not written down? Isn't it a 1? If there's no number in front of x, then it's a 1. Same thing with radicals. If there's no number in front of the radical, there's a 1 there. So this is saying 1 root 7 plus 1 root 7. So you just add the numbers in front and you leave the radical the same. So this becomes a 2 root 7. All right, let's go on to number 3. There's a problem with number 3. Can anybody recognize the problem with number 3? You recognize the problem? There is a problem. What's the problem with number 3? Excellent. The numbers in the radicals aren't the same. Are we allowed to add radicals that aren't the same? No. Can I simplify 5 or 7? Can I break it down at all? Nope. So this cannot be, this is already simplified. We can't simplify any further. So we just write 4 root 5 plus 3 root 7. It cannot be added any more than this. And now the same rules go for subtraction. So if I have an 8 root 2 minus a 5 root 2, that's going to give us 3 root 2. You guys do actually, I'm going to do number 5 with you. 6 root 11 minus 6 root 11. Isn't that 0 root 11? But what's 0 times anything? 0. So this answer is just 0. And this makes perfect sense that our answer is just 0. Because if I have a number and I take that exact number away, aren't you left with 0? That's what this is saying. I have 6 root 11, and then Stella takes the 6 root 11 from me. I'm left with nothing. I'm not left with 0 root 11. I'm left with 0. I have 0 root 11s, but that's ultimately 0. All right, number 6. I can't simplify anything, and I could only add or subtract ones that are sort of like terms in the sense that they have the same radicand, they have the same number underneath. So out of all 3 of these, I can only add the 2 root 5 and the negative 8 root 5. So what's 2 root 5 minus 8 root 5? Good, negative 6 root 5. And then you just bring down the plus 9 root 7 since I can't add them. All right, for number 7, none of them have the same radicand. None of them have the same number underneath. But there's a difference with number 7 and all the ones we just previously did. What's the difference? What can I do here? My question is, right now I cannot add them as they are because they all have different numbers underneath the radical. But like, for example, in number, what number? Number 3, I couldn't add them because they didn't have the same number underneath and there was nothing I could do. So I just rewrote it and said, this is completely simplified. But in number 7, it's a little bit different. I can't just write, this is completely simplified. Why not? Good, because can I break 18 and 20 down? Can I find pairs there? So that's what we want to do. If you can simplify the radical, you have to simplify that radical. So 18, I'm going to go with 9 and 2. For 9, I'm going with 3 and 3. We're looking for pairs when we're simplifying. So every number I circle comes on the outside one time. Since I circled one group of 3, only one 3 is coming out. And whatever is not circled and not crossed out goes back on the inside. So this becomes 3 root 2. Now for 20.
Wait,
yeah.
Would it matter like
Nope. So what numbers were you thinking? 6 and 3?
Yeah,
Okay, I'll show you. So if you did 6 and 3, you'd break down the 6 into 2 and 3, and then you'd circle this group of 3s. And then you'd pull the 1, 3 on the outside, and you'd still get a 3 root 2. So no matter which factors you start off choosing, it will bring you to the same end spot. It's just a different process of getting there. All right, Sebastian, break down 20 for me. Ten and 2? I like that. All right, break down 10. And what? 5 and 2. Is it okay that I circle numbers from different branches? Absolutely. So now I circled one pair of 2s. That's coming on the outside. What's going on the inside, Sebastian? Whatever's not crossed out and not circled. 5. And then I'm just going to bring down that minus root 5. So now all my radicals are completely simplified. Now that all my radicals are completely simplified, now I can combine the ones that are the same. Which ones are the same that I can add or subtract? Stella? Minus 1 root 5, right? So now that 3 root 2 stays the same, nothing I could do there. But then when I have 2 root 5 minus 1 root 5, what is that, Leilani? 1 root 5, you got it. So we have 3 root 2 plus 1 root 5. Do I need to put the 1 in front? No. If you wanted to, it's still okay. Okay, the square root of 121. Remember I had told you we need to memorize the perfect squares. Well, 121 was a perfect square, wasn't it? 11 times 11. So there's a pair. Whatever I circle comes outside one time. Is there anything left on the inside? No. Then I move on to 2 root 6. Any pairs that I'm going to make out of 6? No. So I'm going to leave that as 2 root 6. Then it brings us down to 2 root 24. Can I get pairs out of 24? Yeah. So let's start breaking that down. Give me any two numbers that multiply to 24. Does not matter which ones. J. 4 and 6 is perfect. Then I'm going to break down the 4 into 2 and 2. How come this time it wasn't worth me breaking down? This time I'm not breaking down the 6, but this time before I did break down the 6. How come sometimes I break it down and sometimes I don't break it down? What makes me decide whether to break it down or not? What are we looking to create? Jonah? A pair, a group of 2. So here I realized, well, if I break down this 6, I could group of 3, right, together. So that's why I broke it down. But here I already circled the 2. If I break down the 6, will I get any more pairs to make from different branches? No. So for that reason, I'm leaving it. And for the other reason, I broke it down. So this is going to be a 2 root, oh, sorry, not a 2 root 6. A 2's coming out, but what's already on the outside? A 2. So this is going to be 2 times 2, which is 4 root 6. Jack M, out of all of these, what are the only 2 I can combine? Perfect. So now I'm going to combine those. And if I have a 2 root 6 minus 4 root 6, isn't that a negative 2 root 6?
Wait, sorry.
Mm-hmm.
The 2 root 24, why did you times 2 times 2 and you got the 4, but for the other one you didn't?
Because there was already a 2 on the outside. So here I had 2 times 2 root 6, which gave us the 4 root 6. Yes, Jack. Yeah. All right, let's do number 9 together. 175 is a little bit bigger, but remember last class I told you tricks to know if something's divisible by something else. So right now this ends in a 5. Since it ends in a 5, what does it have to be divisible by? 5. Yeah, if it ends in a 5 or a 0, it has to be divisible by 5. So on the side of my paper, I'm going to do 175 divided by 5. 5 goes into 17 3 times. 3 times 5 is 15. 17 minus 15 is 2. Bring down that 5. 5 goes into 25 5 times. So it goes in evenly as it should. So I'm breaking down that 175 into 5 times 35. Maya, what should I do now? Excellent. I can break down the 35. And when I break down the 35, I'm going to get 5 times 7. Is it okay for me to circle the 5s from different branches? Absolutely, that's okay. Now, how many 5s am I writing on the outside? 1. And what's left on the inside? A 7. Perfect. So I have 5 root 7. I'm going to bring down the negative 3 root 7. Can I break down the 28? I sure can. Noah, could you break down the 28 for me? Perfect. And then the 4 becomes 2 and 2. So whatever I circle is coming on the outside one time. So the 2's coming on the outside and then 7's left inside. Since they're all root 7, root 7, root 7, can I simplify all of them together? Yeah, so let's just do 2 at a time. So if I have 5 root 7 minus 3 root 7, what does that give us? 5 root 7 minus 3 root 7. 2 root 7, perfect. But then if I have 2 root 7 minus 2 root 7, I have some quantity and I'm taking that same exact quantity away. What is that? 0. Yeah, if I have some quantity and I take that exact quantity away, we're left with 0. All right, I want you guys, I'm going to only ask you to do 2 of them. I ask you to do number 13 and number 11. Do numbers 11 and 13, and then we'll move on. Okay, as soon as you finish number 11, raise your hand. I'll come up here. I'm just picking number or number 13. You started number 13 since I said that first. We can see now. Let's see. That's right. Let's see what you did. So here, this is your pair, right? The 4 is already on the outside. It's not part of the breakdown. So when you bring this outside, you multiply it. So this is 5 times 4, which is 20. It's not divided with 4. That 4 is not left over from the breakdown. Does that make sense? And then you can break down 9 too. Anybody want my help? So whatever you circle comes on the outside how many times? Once. Only once, because you circled only one circle, only one number is coming out. So there's already a 2 on the outside. So what do you do with that 2 and the 1, 3? You multiply them. So it's always this. So you have a 2 times the 3, which is that. Is there anything left over from the breakdown? No, so nothing's back inside. So it's just the 6. So let's do this one. Yeah. 20. Yep, anything left over? No, and then there's a plus between them, so you put a plus there. Then you add them. This one. Let's erase. You're right. It's not. I want to erase this. So let's start on for 2 right now. We can break down the 9. What multiplies to me? The 3 times 3. Thank you. There's not like things like 3 but there was no pair, right? So we're always looking for a pair. And whenever the circle comes on the outside, how many? 1. Are you interested? Yes. Nothing's left over, right? Well, we just don't write anything. If there's nothing left over, we don't write 6. Yeah, that's it. Or is that first one like done yet?
Don't say that.
What?
You're gonna not be for. Yeah.
Nothing's left over, right? And then 20 plus 6 is. No, yeah.
So whenever there's nothing.
5 times 9 is 45.
They're done.
Just that they don't.
Sorry.
But now, who's the problem? Oh, we can get it.
So remember I said if we can get a pair from something, we break it down. So you kept breaking down, right? Cross off the ones you break down so you know they're done. And now there's a 10 and a 2 left over. But if I break down this 10 to a 5 and a 2, I could get another pair right here.
So now I have 2.
Same thing we were doing before. So you take 1, 2, so there's a 2 on the outside. You're gonna pull another 2 out from this circle. You're gonna pull a third 2 out from this circle. And then we're just looking at the 5 on the inside. So 2 times 2 times 2 is 8.
So then this would just be 8 root 5. Or it would be
12 root 5.
wait,
We are.
So this is root 0. Yeah, so
Something on the cheese.
that eraser was cool. So now these two are like, you're gonna have like 2 minus root 5 minus 10 root 2. Perfect.
We're listening to it.
So I like it was yes. So I didn't on any service. So these on our service. This is not part of it. This tube was already on the outside. So it's not gonna get put in. It wasn't part of the breakdown of the 9. So only what's broken down gets put back in. So we start with that 3, it's coming out, and there's a 2 on some side. So you just divide the 2 and the 3, and that's a 6. Nothing's left over to go back.
oh no.
So now let's talk about here.
The document
opens
from, but it's just. And then I was like.
20 left over. No, so it's just a 6.
Oh,
I still like a. Yes.
But there's a 4 on the outside, and we're plus 3 out, so there's multiply by 2 outside. 4 times 3.
I just didn't simplify it.
So that's gonna be a 12.
I stayed. Like, it was just.
Yeah. Got it.
Or we run out of.
Guys, I'm still around to check the roots or you know how to do this.
Like, I thought I did it right, but I'm not here.
This is good. This is good. This could still get broken down because we could get pairs from the 20.
Yeah.
So you could just keep going and just break down from here.
Wait, so like when I can still get pairs for something, it doesn't matter if I already have a pair.
Yeah, you could get multiple pairs. Guys, let's actually do these together. So right now, for number 11, I was walking around. I was really happy that I saw a lot of you notice the pairs right there. You got your 3 and your 3. But keep in mind, that 2 is not part of the breakdown. That 2's already on the outside. It's sort of safe already. So it's not going to go back into the house. It's already on the outside. It stays on the outside. So when you do is you're going to pull 1 3 out, but that's going to get multiplied with the 2 to make a 6. And then after you do that, nothing's left over. It's just a 6. For the 25, we're going to break that down into 5 and 5. There's a 4 already on the outside. So you do the 4 times a 5, which is a 20. Nothing's left on the inside here. So this gives us 6 plus 20, which is 26. All right, then we want to do number 13. So for number 13, again, I saw really good stuff with breaking down the 45. We went 9 and 5. And then for 9, we went 3 and 3. Now that 3's coming on the outside, but what's already on the outside? A 4. So what do I do with the 3 and the 4? Multiply. So that's how I'm going to get 12 root 5. This time there was a number left over from the breakdown. That's why it's going back inside. For number 8, I'm sorry, square root of 8, I'm going to break this down into 4 and 2. And then the 4 becomes a 2 and 2. Right? There's a 5 on the outside, but I'm going to bring another 2 on the outside, which gives us a negative 10. And then there is a number that's not crossed out and not circled. So that's going to be a root 2. 80 was the biggest problem here. So I think most of you went with 10 and 8. And then you did really good with the 8. You did 4 and 2. And then you did 2 and 2, which is really good. And I'm happy about that. But we can have more than one circle. You're allowed to circle more than one pair of numbers. So now I'm going back to the 10. And I ask myself, well, if I break down the 10, can I get another pair? And my answer is yes. Right here, I can group these 2's together. So what does that mean for me? That means I already have a 2 on the outside. I'm going to bring the orange 2 on the outside and the black 2 on the outside. And the only number left over is a 5 for the inside. So 2 times 2 is 4 times another 2 is 8. So this is plus 8 root 5. You want as many pairs as possible. You want as many pairs as possible. If you can get another pair. If you don't know if you can or not, break it down to see. Yep. So your goal in simplifying is to get as many pairs as possible. So there's no limit to what we can have. And now out of all of these, only 2 of them can be added together. So 12 root 5 plus 8 root 5 is a 20 root 5 minus a 10 root 2. Okay, so I think we need a little bit more practice before we move on. So I actually want you guys to do 10 and 12 also. Do 10 and 12. Anybody want my help?
Yeah, I mean, so, no more pairs, right? So you're gonna put 110 on the outside. And then on the inside will just be a 3 times a 2, which is 6.
Okay.
Who remembers how do you know if a number is divisible by 3? Yeah. So what's 9 plus 6? 15. Is 15 divisible by 3? So 96 is divisible by 3. How do you know if a number is divisible by 6? No? All right. Remember, if it's divisible by 2 and it's divisible by 3, then it's divisible by 6. Well, we just said 96 is divisible by 3. And how do we know if it's divisible by 2? It has to be an even number. 2 ends in a 2, 4, 6, 8, right? Or 0. If it ends in a 0, 2, 4, 6, or 8, it's an even number. So since 96 is divisible by 2 and it's divisible by 3, that means it's divisible by 6. So you can go little like 3 or 2, start off there, or you could go big as 6 if you want. We ready? So what's 12 root 3 minus 5 root 3? Easy peasy. 7 root 3. All right, so for these two, we have to break down how many people went with 2, like divided by 2 first. How many people divided by 3 first? How many people divided by 6 first? All right, let's go by 6. So I'm going to do 96 divided by 6. 6 goes into 9 one time. 1 times 6 is 6. Subtract. 9 minus 6 is 3. Bring down the 6. 6 goes into 36 6 times. So now I'm going to break this down. So this is the root of 96 plus the square root of 600. All right, so 96 is going to be 6 times 16. And then 16, I'm going to choose pairs. So I'm going to go in 4 and 4. I can break down the 6. Let's just say I broke it down. I broke down the 6 into 2 and 3. And then I realized, are there any more pairs there? No, that's okay. I know a 4 is coming on the outside. What do I already have on the outside? A -1. So this becomes -4 on the outside. And now what's left are the two numbers I didn't circle or cross out, which is a 2 and a 3. Just multiply them together and put them back inside, which is a 6. So that's okay if you over break things down. To be safe, just multiply them back, put them underneath. And now for the 600, I'm going with 6 times 100. The 100 is 10 and 10. This time I'm thinking ahead and I'm not breaking down the 6. Why am I thinking ahead and not breaking down the 6? Because there are no pairs I can make, no more pairs that I can make. So we're going to have plus 10 root 6. So now I'm left with -4 root 6 plus 10 root 6, which is 6 root 6. So I think before we go on to multiplying, I think we need more practice simplifying. So what I'm going to do tonight, I'm going to stop here, but what I'm going to do tonight is I'm going to assign you the simplifying homework that I wasn't able to assign because of the homework free zone. I'm going to assign that to you, and then we'll go over it next class. Sound like a plan? So we'll